As many of you may know, prescribed burning is a common management tool in the Midwest and Eastern United States to encourage oak regeneration. In the Morton Arboretum alone, in the East Woods, we have 3 distinct fire regimes that are taking place. We have an area that is burned annually. We have an area that has been burned for the first time this year, and then we have an area that rarely receives burns throughout Arboretum history. Now, before we talk about, so here you can see that some of the effects of fire are very visible, and as Sam was saying before, other effects are not visible, what's going on underneath the ground in the soil. So when we're looking at how fire affects soil characteristics, one of the main things you have to take into account is temperature. And so temperature plays a large role in how that fire is going to affect the soil. So if the fire is really hot, you can lead to decreased organic matter and decreased microbial communities, which can also decrease nutrient availability. It can also just volatilize nutrients. However, in the Arboretum, we specialize in low-intensity fires, which hopefully are going to retain that nutrients, not getting to the level of severity where we're losing those nutrients from the soil. And while I couldn't measure the amount of temperature that was happening in these burns, it took place back in April, we were able to look at other characteristics such as the soil here and see if we're seeing our expected effects of the soil. There's a process called an ash effect, where after a fire goes through the soil, it leaves behind basic nutrients such as calcium and magnesium, potassium that increase the pH of the soil or decrease its acidity. Now, as Sam walked us through the nitrogen cycle a minute ago, I'll do a little bit simpler version here. The reason I wanted to look at nitrogen specifically in the soil is because it is one of the most important nutrients to plant growth. It is a large component of chlorophyll, it's a large component of proteins and amino acids and nucleic acids that make up our DNA. So when we have our organic matter that goes into the soil, we have a pool of organic nitrogen that, as Sam said, goes through a process called mineralization that leads to a pool of ammonium. Now, this ammonium is available to the trees and other plants, so they can take this up and use it in their growth. And so we have this pool of ammonium that's available to the trees. However, not all of the nitrogen in the soil stays in ammonium. It also goes through a process called nitrification, where we have another pool of nitrate, which is also available to these trees. Now, these 2 pools of ammonium are not just remaining in the soils throughout time, they also can go through other environmental processes, such as gas loss and leaching, which can cause environmental factors that decrease in nitrogen in the soil. So for my project, I'm looking at 3 specific areas in the forest that are affected by the fire. One, I'm looking at the soil, I'm looking at the nitrogen availability in the soil. I want to also see how the nitrogen is affected in the trees. So I was also sampling the adult canopy leaves from several trees throughout the Arboretum. And I also want to see how it's affecting the seedlings. Because as we saw in those first pictures, the understory is dramatically affected by fire throughout the woods here in Arboretum. So for soils, since we have low-intensity fires, I've hypothesized that when we have more fire, we're going to have more nutrients. We're not going to see that nutrient loss since we have our low-intensity fires. So as you see over here, moving from annual fires down to rare fires, I expect to see a decrease in the amount of nitrogen in the soils. I also expected to see the same trend with foliar nitrogen, where we see that annual nitrogen is high in annual burns and then decreases as you go down to the areas that are rarely burned, which would cause a positive relationship between soil nitrogen and foliar nitrogen. As soil nitrogen increases, we expect foliar nitrogen to increase. And then for seedlings, a little less complicated, I expected species that are fire tolerant to have higher populations than species that are fire intolerant in annual burns and corresponding relatedly as you go down with decreasing numbers of fire. Now, for my project, I was focused only in the East Woods natural area, and I had 9 plots total spread across the 3 fire regimes. You can see here, red is representative of annual burns, yellow is representative of recent burns, and this blue turquoise color represents the areas that are rarely burned. Now, in these plots, I had 4 specific species that I was interested in studying. I wanted to see how fire was affecting sugar maples, ironwood, white oak, and red oak. And these are all very common species in Now, once I found the trees that I was interested in studying, I set up this sort of experimental design where I had 4 subplots in cardinal directions around each of the trees. In each of these subplots, that were 3 by 3 meters, I was able to count all of the seedlings, and I also took soil samples and then light measurements as a control. For the tree itself, I wanted to sample from the canopy, as I said, to get those foliar nitrogen readings. So when you go walk into one of my plots, it kind of looks like this. There are 16 subplots total per plot, and in those subplots, like I said, I was able to measure the soil and seedling populations on my own. However, I needed a little bit of help getting to the canopy of the trees. So I was lucky enough to have the arborist crew took a day to help me collect all of my samples. They're absolutely wonderful. They use this air pressure gun called an APTA, where it essentially shoots a line into the canopy, and then you can use the line to pull down leaf samples. So after they were pulled down, I've got my bundle of leaves that I was able to take back to the lab, and then photograph them, dry them in the oven, and grind them with a coffee grinder until I was left with these beautiful green vials of green leaf dust, essentially. Every tree, all 36 trees that I sampled, are now represented by little vial of dust. In the soils lab, I was able to use an instrument called Elementar, which combusted them, as Alyssa was saying earlier. They're in these tiny little tinfoil packets, and it combusted at high temperature, and then we can get the amount of carbon and nitrogen in the leaf sample from those measurements. While I was in the soils lab, I obviously also sampled the soil. And so after I went through and collected all my soils, next day I did extractions, and I was able to find the amount of ammonium and nitrate specifically in my soils at that time. And from there, I was able to calculate the nitrification and mineralization rates, there we go, in the soils. I also measured the pH of the soils. So what were my main results? Start at the bottom of the soils. Overall, we saw the same trend that we expected with pH. Here we're looking at pH with acidity increasing, decreasing with acidity, pH increasing, decreasing acidity. And on the x-axis, we have our burn treatments, annual burns, recent burns, and rare burns. And here we can see that we have different letters around each of these treatments. Different letters mean significantly different results. So here I want to focus that our annual burns had the highest amount, had the highest pH, which is what we expected from that ash effect. However, when we started looking at the amount of nitrogen, we did not see what we expected. You remember we predicted that more fire was going to result in more nitrogen. However, this was not the case. When we went through and measured mineralization specifically, we found that annual burns actually significantly decreased the amount of nitrogen available in the soils compared to the recent and rare burns. That one fire was not significantly affecting mineralization rates. And when I looked at the other nitrogen levels that I measured in the soil, such as nitrate, total inorganic nitrogen, and nitrification rates, I saw this same trend. Overall, the message was clear. In my 0 to 5 slope horizon that I measured, nitrate was lowering with more fire. Moving on to foliage. So now we know how it affects the soils. How is this affecting the leaves? If you remember, we expected to have the same trend as the soils, and we are. We're seeing the same trend here, where annual fires are decreasing the amount of nitrogen per area in my leaf samples. So you see here that these are not significantly different, but we really see a difference here between the annual and the recent burns. And we're thinking that maybe this spike in the recent burn nitrogen in our leaves might have been due to higher levels of nitrate that were available because we were burning larger amounts of woody materials in this area. Since it was burned for the first time, there was more organic matter, maybe to cause that increase in nitrogen availability for the trees. Now, bear with me here for a second. What we're seeing here is that, once again, that relationship between foliar nitrogen and soil nitrogen. We're seeing that positive relationship across all of the tree species. But here we are able to break it down by tree species and look at foliar nitrogen as well. And so what we see here is 2 different groups. We have the oaks up here, red oak and white oak, as well as the sugar maples and ironwoods here at the bottom. At the top, pretty much what this is saying is that foliar nitrogen is higher in oaks compared to sugar maples and ironwoods. And this is to be expected, as Sarah was saying earlier, different leaves have different amounts of thickness, and oaks are specifically very thick compared to sugar maples and ironwood. So here, when we're looking at nitrogen per area, there is just more mass per area in an oak leaf, so there's more nitrogen in those leaves. Moving on to the seedlings. For this project, I ended up counting 9,412 seedlings throughout the summer. However, most of the seedlings that I counted were sugar maples, represented here with blue. This does not count, this is density. I did not measure 2 million, just 9,000. So you see here, we can see that our recent burns, we have quite a few sugar maples, as well as this rare is just absolutely dominating. We can't even see the relationships for the other species. So if we go ahead and take out those sugar maples, we can see some interesting trends going on. First of all, in the annual burns, we see that oak seedlings absolutely dominated areas that were burned annually. And this was to be expected as they are considered a fire-tolerant species, and after all, we're burning to help oak regeneration. So this was expected, and we hope to see this. However, another interesting trend we see here is that these green bars here are representative of ash seedlings. And while they are a large component of the seedling population in both recent and rare fire treatments, these ashes will never make it to the, will never be good competitors for spots in the canopy because of the invasive emerald ash borer is decimating ash populations. So while we're seeing them dominating in the seedling populations, we would never expect these to be viable competitors for spots in the canopy in the future. Breaking it down by species, I want to make sure we're looking horizontally here. We cannot compare between because our axes are not the same. But we're seeing our trends that we expected for fire-tolerant species. Here we have oaks and hickories. And while we're not seeing quite the trend we were expecting, we are seeing that there is not a significant difference between areas that are burned annually and areas that are burned rarely. So essentially, the oaks and hickories don't mind if they're burned every year or if they're never burned at all. They're fine either way. However, we are seeing this decrease in that one recent burn. Just one burn was not enough to increase these fire-tolerant species populations. When we look at fire-intolerant species, we see a bit more of a clear trend as we predicted. Here in the sugar maples, just to remind you, we're talking about about 10 times more sugar maples compared to all of the other species. So just don't forget, we're not comparing down, we're comparing across. Here, once again, you can see we have these beautiful trends where very low populations of fire-intolerant species in the annual burns, with increasing some in the recent and doing very well in areas that are rarely burned. So overall, what did I find? We expected that areas that were burned annually would increase in nitrogen. However, this was exactly the opposite of what we found. Areas that were burned annually had the lowest amounts of nitrogen compared to the other burn treatments. And this decrease in soil nitrogen also translated to a decrease in foliar nitrogen. So we are seeing that full loop in the nitrogen cycle where the soils are truly affecting the amount of nitrogen available to leaves. And then for our seedlings, we saw that our oak regeneration was increased with those annual burns. Our sugar maples were decreased. So the management was doing what we were hoping it would do. However, that one recent burn was not enough to eliminate sugar seedling populations or increase oak populations. In the future, I think it'd be very interesting to look at other soil characteristics so that we can pinpoint down some of the reasons that we're seeing our decrease in nitrogen in the soils, including sampling deeper soil levels. I would like to increase the sample size of the trees so that we can understand the relationship between fire treatments, species, and foliar nitrogen better and draw more direct conclusions from that. And then I would also like to include seedlings and saplings into the study and maybe get foliar nitrogen samples from them so that we can see across species how are they doing across their lifespan in the different fire treatments. I'd like to take a minute to thank my mentor, Dr. Sylvia Olivares-Clare and Christine Carrier for making this program possible. A big thanks to Dr. Michelle Midgley and Dr. Megan Midgley, and Michelle Catania in the Soils Lab and all the Soils Lab volunteers who helped me so much this summer, were patient with me and made me feel welcome in the Soils Lab. I also want to thank the Arborist crew again who took a day out to help me with my foliar collections. Thank you to the Center for Tree Science for being my home for the summer, and of course, Morton for providing funding. I'll take any questions.
Did you do anything with the seedlings? Because you can look at the notes to figure out how old they are? Did you do anything to look at the age of the seedling?
No, I didn't. It's so interesting. I didn't know you could do that. I did include saplings that were less than a meter tall. Generally, that's how I ranked my seedlings. Anything less than a meter was included in that pool. And so I was able to make some visual observations with saplings as well, but it was nothing concrete in numbers. So, no, not too much on page. In the future.
You saw a decrease in nitrogen with the annual burning.
Yes.
Could that have been caused by the fact that the nitrogen was mobilized or volatilized, so it was a lot of it initially, but then it washed away or vaporized?
It's very possible. While our fires are considered low intensity, so in theory, the fire itself shouldn't have been removing the nitrogen from the soil. It is possible that when it was in those ammonium and nitrate pools, that it was leached from the soil. If there was a lot of rain, or if the soil is less compacted, you release back into the air. So there's definitely other environmental factors to be taken into consideration here.
Do you think that decreased nitrogen content might affect the establishment of those oaks? So whether or not the seedlings survive to become full trees?
I think that is an excellent question and something that needs to be investigated more, because that's why I would like to get a better sample size of the trees, and then also look at how the foliar nitrogen is interacting with the seedlings to see kind of, is the soil nitrogen affecting the seedling nitrogen in the leaves. So I think that definitely needs to be expanded upon, and I was originally hoping to be able to do that this summer. However, our seedling populations, as you saw, are all over the place between annual to rare, so it was hard to get a species or enough